Okay, so we're going to continue to take a look at washers. So we're going to have a sideways parabola. We have a diagonal line. We have y is equal to 0, which is the x-axis, and y is equal to 2. We graph all that, and we are looking for the region that's bound by all that. We have our x-axis. We have our parabola. We have our diagonal line. Then there's actually a y is equal to 2 here, which really is where it crosses here, so it doesn't really come into play. So you're looking for the region that's got bounded by all of these, which is shaded over here. So at this point, all we have to do is revolve it around our y is equal to, or x is equal to 1, which is right here. So since our shaded region does not touch our axis of revolution, we know we're going to have a hole in the middle, so it's a washer. It's a vertical axis of revolution, so we know we're dealing with y's. So since we're dealing with y's, it's got to be how far up and down our shaded region goes. Goes at 0 all the way up to 2 for your bounds. So now we have to go ahead and take a look at your big radius right here, which would be the bigger of the two radii going from the outside of the shaded region to your axis of revolution. So we have to go what's on the right, which is our parabola, minus what's on the left. So what's on the right is our parabola, minus what's on the left, which is just 1. Then we have to do our hole, which we have to go right minus left, which is our diagonal line, minus what's on the left, which is 1. So we have our diagonal line minus what's on the left, which is our 1. And each one of those has to be squared because we're dealing with washers. So we'd want to go ahead, simplify a little bit. 6 and minus 1 is 5, and our 4 minus 1 is our 3. You'd want to FOIL this out, distribute through your negative, collect like terms, and we get this. Now that's pretty easy to integrate, so you integrate, plug in your 2 minus what you get when you plug in your 0, and plugging in 0 doesn't change anything. Now, you could go ahead, take what we have right here and put it into your calculator. You know you're going to have pi in your answer, so don't put pi in your calculator, just type this in. Well, to do that, you would go math down to your integration 1, and you would type this in. If you have a newer calculator, you can arrow down, put in 0, arrow up, put 2, and then type it in just as you see it. But remember, your calculator only deals with x, so wherever you see a y here, you got to put an x on your calculator. Since we're not dealing with roots, it should work out to be nice, so that means all you do once you get this is you just hit math and enter to turn it into a fraction. And you'll notice how we just typed in this part here without the pi, so you just have your fraction from your calculator with a pi on it. So that's an easy way for you to be able to check your work. So here we have a vertical axis of revolution again, so therefore we know we're going to be dealing with y's. Here we have is x is equal to -3, which is a vertical line. We have this, which would be a sideways parabola. No, a normal parabola, sorry about that. And then we'd have y is equal to 4, which is a horizontal line at a height of 4. If we graph that, we would get this. We would have our parabola. We'd have y is equal to 4. We have x is equal to -3. We're looking for the shape that is bounded by all three of those, which is this shaded region. We're revolving around this orange dotted line over here of x is equal to 1. Since we're dealing with y's, it's got to be how far up and down your shaded region goes, which goes from 0 all the way up to a height of 4. So that's your bounds. Then you have to go ahead and do the big shaded region. Well, your big shaded region would go from the left side to the right side here. So when you're looking at the length of this red segment, you got to go big minus small, which is your axis of revolution of 1, minus what we have over here on this side, which is negative 3. So 1 minus a negative 3. Then when we're looking for our hole, the unshaded region, you have to go what's on the right, which is your axis of revolution of 1, minus what's on the left, which is your parabola. So it's 1 minus your parabola. And then each one of these underlined would also have to be squared. So we just basically get 4 squared here, which you know is 16. I would probably distribute through the negative, combine some like terms here. Now, I'd probably go ahead and FOIL this out, 4 minus root y times another 4 minus root y, and square that. So we get our 16. FOIL that out, distribute through your negative, collect like terms, and we end up getting this. Now, this is pretty easy to integrate. Remember that root y is really y to the 1/2. So you can integrate, plug in your 4 minus what you get when you plug in 0. And when you plug in 0, you should realize, because all these have y's, it doesn't change anything. And then you get 404 pi over 3. Here we have an axis of revolution that's y is equal to 2, which is a horizontal axis of revolution, so we know we're dealing with x's. If we graph this, we have our parabola. We have a horizontal line at a height of 5, vertical line at our y-axis, and a vertical line 1 unit to the right of y-axis. If we graph that, we look at our shaded region. Our y or x is equal to 1, x is equal to 0 right here, our horizontal line of y is equal to 5, and our parabola, so we're looking at what's in between all those, which is right in this region. Our axis of revolution is our y is equal to 2 down here, because the shaded region does not touch our axis of revolution. When we revolve it, we end up getting a washer. We're dealing with x's, so it's got to be how far left and right these go, which starts at 0, goes over here to 1. So that's going to be our bounds. Then we have to do our big radius. Our big radius would be the red, outside of the shaded region to our axis of revolution. So we got to do the top, which is our parabola, minus our axis of revolution. It's always big minus small, so it's the big of our parabola, minus our axis of revolution, which is the 2. Then we'd have to do our inner radius, which is where the unshaded part region here is, which goes from our line of 5 to our line of 2, so it'd be 5 minus 2. And then we'd have to square that because we're dealing with parabolas, washers. So when we look at the inside here, we can simplify that. We can simplify this. Well, that's pretty easy to integrate. We just have to FOIL this out. Still with our 9 being subtracted. Now we could easily go ahead and integrate, increasing your exponent by 1. And by the way, 16 minus 9, you know, is a 7. So we get a 7x. Plug in your 1 minus what you get when you plug in 0. And in this case, we get 68 pi over 15. One last one here with a vertical axis of revolution, a horizontal axis of revolution. We'd have our parabola. We'd have a horizontal line here. We'd have a vertical line here. We graph all 3 of these, our parabola, horizontal line, vertical line. Our parabola, our horizontal line, our vertical line. This is the region that we want because it's bounded by all 3. We have our axis of revolution right here in orange. Notice your shaded region does not touch the axis of revolution, so when you revolve, you get a hole. We're dealing with a horizontal axis of revolution, so we know we're dealing with x's, so it has to be how far left and right your shaded region goes. Starts at 0, goes over to 2 for your bounds. Then you have to do the bigger radius, that's the longer of the 2. So that's going from your function down to your axis of revolution. So it would be your parabola, your function here, minus your axis of revolution, which is minus a negative 2. I don't know if you can see that little negative right there underneath the crosshairs. In other words, that's really negative 1 plus 2, which is where we get that positive 1. Then when we look at the inner radius here, that's going from a height of negative 1 to your height of negative 2 for your hole. So it's the big minus the small, the negative 1. There's a negative there, minus your negative 2, and there's a negative there. Negative 1 plus 2 then, you know, is 1, and it's got to be squared. So FOIL this out. The 1's drop, so you just have to integrate this part. And we get that. Plug in your 2 minus what you get when you plug in 0. We get 176 pi over 15.